Okay, make sure to read the description. Just finished typing that. So I need a new enum called orientation. And I'm thinking about if that needs its own header or if I can probably just add it to the BezierFitter. Yeah, because a new member function of the BezierFitter is going to use it. Let's call this perpendicular. Hey, AG. Read the description, I would say. Of course, I'm reading it right now myself. Let's see, range domain, rectangle, viewport. And then I get double fraction orientation. Okay, what about that? So this has to be implemented now. Let's put it here. Let's put it here. No, let's first just use the old function. So ignoring v, just pass domain, viewport, and I set that to -1, which then automatically ignore orientation, just to make it compile and link and work. So we have to call it as well somewhere. Yeah, what test shall I use? I think that circle Bezier is still crashing. Not even sure though what the reason was. It's false. Plot. Oh, that. Yeah, that's not a function, I think. There's a bunch of points. What is this doing? No, not much. So yeah, there's a Bezier here. The F is Q then. Q is just the direction. This is starting in P0 and P1 and then going through P comma with a given derivative. So it doesn't really seem interesting. Bad is not even used. Yeah, I'll leave it in, but nobody will use it, I hope. Maybe I should make a new test. There's a lot of code duplication in the meantime, I think, between all these tests. It smells a bit. This draws a function, but yeah, it's just a single Bezier. It's hardly interesting. I need a simple test that draws a simple function. Just not believe this draws functions, but it's about something else. These are functions. In the end, I want to replace that old function, I think. Well, not totally replace it. So it might be that you just have a function, a simple function, and you don't have the derivative of it. But yeah, I could draw these using my new function, I guess, and then we don't have to write a new test. This is a lot of functions to be drawn. Like a double usage of the test, not really. You should do maybe, but I'm going to abuse this one because it has functions. But yeah, that does mean that whatever the function is, I have to be able to get a derivative of it. This is the red one. Is the red one usable? Yeah, it's totally usable. It's some cubic. So if we remove this one, see, BezierFitter, the plotting is still done. It's the same way, but I have to replace this to the parameterized constructors calling the solve. So do that in 2 steps for a start. I just construct it and then I call solve with the function and a domain. You don't have a domain, viewport. So what does BezierFitter use by default for the domain? If you don't pass the domain, then you are here. No domain. Yep. So the domain is simply that in that case. The x coordinate interval of the viewport. Let me also pass an orientation and a fraction. So the fraction is maybe 10,000, and then the orientation vertical. I forgot to pass V, I suppose. Right, so this is P. And now we have to this is a vector, right? Return something. That must be the derivative, I think. So the cubic is relative to x1. No matter. I need the derivative of this cubic. Currently we are ignoring v, so let's just return 0. Wait, I must return a vector. Just as long as it compiles. Yeah, there's something. This returns a vector. I don't think I have that actually. So my new solve is taking. It's returning a point. That's not the idea. Vector. Run. Hello, Amar. Something went wrong. Reference to non-static member function must be called. Okay, so that was the red one. Still works. Now I can implement it. At least you have a test function now that calls my new function. I think the general idea of this function is it gets values from the function and then it fits something And then either it says the fit is yay, so we store it in the result, or the fit fails, and then we split the thing in two and we call solve again recursively. Solve. Note the F does this thing pass at the end. A shitload of points and a T0 and a T1 or something. That is this function, T6, T0 and T6. I never saw this one implemented. I only saw this one, damn it. We should have used this one, the private function. This one's way more important. Yep, so we need something like this as an extension of the new function, this one. Well, the difference between this one and that one is that now we also pass a v, and I replaced the tolerance with a fraction and an orientation. Yeah, there's two things, two straightforward things, so we can do the same thing here, I think. Just duplicate this, and then we call func p. And then we add a v, which is a function that returns a vector. And then tolerance is replaced with fraction and orientation. However, this is the parameter. I'm not sure I want to call it T0 and T6. That's more the Chebyshev name of the things. But they just stand for the leftmost and rightmost values of the parameter at that point. So we can call it T0 and T1, I think, in this case. Well, who cares about the 6? Begin and end point. And then these values. Yeah, I think there's the function value at t is 0, the function value at t is 6, and the function value at the t value exactly in between t0 and t6, which then we don't have to pass that because it's just a half times t0 plus t6, so we already know that. So this thing takes 3 function values, but we also have a v value. And I guess my function is going to take everything, like, well, let's work with vectors as well. So we have a p0 and a p1. And then this is going to be my p gamma, the thing in between. And we also have a direction vector then, so I'm just going to call this one t0. Why not? The tangent vector in p0, and we have a vector t1 tangent in tangent, yeah, in P1. Now we have to implement that function. Rather, I should have started with that. But okay, I can still pretend my... I was going to say my nose is bleeding. Is that an expression? We'll just call the old function, ignoring almost everything. I don't have a domain anymore. Wait a minute. And p is now no longer is no longer an R value. Okay. Well, never mind. I still need the other one. Fix that in a second. We have this one. It does all the hard work. And this one, which is just the startup. So let's add. Let's just move the new function to the bottom. So I'm going to add it here and then move the whole thing to the bottom. So I'm not going to delete the other one, and then it's more logical to have the old functions first. The new one at the bottom. Well, we don't have a tolerance. Fraction just always has to be set, I think. Let's ignore that also. And then of course you have a begin and an end, which is just the beginning and the end. Except that now I call it D1. And we have to initialize depth. And then I guess I can call my new solve. Private solve p comma v comma viewport comma, the thing was expanded in two things, fraction and orientation, and then well the t0 and the t1. And then all of these, where do I get that from? Oh, it's just being calculated. So we call the function. Okay, not too hard. So we call p. P returns a pointer. I'm casting it to a vector, that's why. So we make a vector of it. And this is then the p and the value, the p at the parameter t0. Yep. And then we have to pass t0 to something, and then again the p1, that would be p at t1. Well, actually, that was that one. Okay, and then t1. And there's a pg here in the middle, which is simply again a vector of p. So in the middle of these two. And here we can pass the v value then of t0 and the v value at t1. Yeah, point velocity. It is just the same functions that are being passed here. And then the viewport and the fraction and the orientation just passed as is, including t0 and t1. We have everything. Oh, they came from the domain, but okay. And then the p0, which is like literally the p at t is 0, and the velocity at t is 0, and the gamma, which is just in between, and the p1, and the v. Yeah, I think that is correct. Which makes you wonder if maybe I should call this t. It doesn't have to be the velocity, it can be just any tangent vector. Let me fix my music. I want to listen to Anime Drop. What the hell? This is not Anime Drop, this is something completely different. Reload. Ridiculous. Yep. Good. Anime Drop is good because it is instrumental, completely instrumental. Very good to work it. This one should be finished. I still have to implement this one, but let's implement this one, not with domain, which I don't have anymore, but more in terms of the private one. And so no move needed anymore. I just use P for the func, and then the viewport, and then the T0 and the T1. Wait a minute, and I need a tolerance though. I'm just going to temporarily create a tolerance from the viewport height. Still have the viewport. Yes, so we just ignore the tangents and ignore the fraction and the orientation. Well, theoretically I could use a fraction here, I guess. So ignore the orientation as if the orientation is vertical, then this would be correct. It's an intersect rectangle. When did that change? So I had a rectangle and then we pass it to the private function that changes it into an intersect rectangle. The intersect rectangle can apparently be constructed from a rectangle. I need a height, however. Do I need a height? I definitely need a height. So now we can only call y1 and y2. It's called PG. Huh? No, mentioning my friends will call to solve. Well, this should be this. What? Which one is this then? That's a private one. So this should be equal to this one. Calling it P, intersect rectangle. That is the viewport. Tolerance. Tolerance is still being passed. Yeah, and I even calculated. I just forgot to pass it. T0, T6, P0, P3, P6. Good. Just forgot to pass the tolerance. This was renamed to T. Oh, that is not working. It's partly working though. I think this is still correct. Hello, Daiwanshu. Tell me, why is this weird thingy there? For the rest it just works actually. Just draws a little bit too much. Possible. What I'm doing should be exactly the same, right? I mean, that's what I'm trying. So, go back to the beginning and just call the old function. This is my solve. So if I just call old function, maybe this is already wrong. I want to call it the way we did before. So let's go get diff. This just passed plot viewport. Should we still be able to do that? I can't be calling the private function because it's private. Did you be able to pass the viewport there? Old function, that means this one. No, this is a private one. This one. But this is way too much to the bottom. And it is not the old function, indeed. This is the old function. So we pass a func and a domain viewport tolerance. Domain viewport tolerance, domain viewport tolerance. Okay. Function domain viewport tolerance. Function domain viewport tolerance. I'm going to pass -1 as a tolerance. I think the solve should be taking a default value, but default value. Now we're talking about. Oh yeah, I was calling this, right, without domain, which then calls solve without domain, but the tolerance is -1 in that case. So I can pass -1 already, and then this solve equals the solve without domain, which then does that. So we can still construct this from the rectangle. That is the viewport, which is being passed and which was passed to the constructor. So I think this is exactly what I had. Well, not exactly, but you know, this definitely wasn't, because viewport, yeah, that is still plot viewport. Plot viewport. I just need something that works. It's like a binary search, this. You have working code, and then you have not working code. And then, well, I first want working code again. It's slightly different than the original. And otherwise I could just have done git restore, but that would be boring. Yeah, this really does working. Yeah, there's just no weird line here. So then what is the difference between this and that? I don't think there should be a difference. for a start, this function, what is being passed here, is exactly the same line as that one. We're going to ignore this one. And this line should be... This line should be the same as that line. Yes. And then we pass the viewport and we pass, well, 1/10,000 and vertical, which are both going to be ignored. So this calls something that takes two functions and a domain and a viewport and so on. There can only be one. It should be calling this one. It's irritating. This can't be hard. Just my memory is not big enough. My short-term memory. Okay, then let's use debug output. I mean, I just can't remember it all. So the new one that doesn't work should end up calling the same function with the same arguments. That's all I do. So this thing calls this one, which is, I think, defined. Well, it's defined here, which then temporarily calls the old one, which is the old private function, which is defined up here. It's this one. So I do the out entering. Notice BezierFitter solve. Yeah, I can't print the function. Just use func. Viewport. Tolerance. D0. D6. P0. P3. P6. So this one works and it calls that function a shitload of times. But I'm only interested in the very first call. Which would be this one. So the viewport is, no, it doesn't change. It's just -20 to -20 to 2020. So that's correct. You can see -2020 to +2020. Well, this is small enough. And then we start at -20. This is the domain, right? So that should be -20 to 20. Just the X range. And then we have 2 points and a point at minus 20, which is minus 20, 19. Well, that would be that one. Oh, now I'm looking at the purple one. I want to look at the red one. Damn it, I should not call the one purple and the green one. That's just confusing. Or, well, I can find it back probably, because the red one is like 13. So we need one that says minus 20, 13 without indentation. That would be this one. Well, that's strange. This one is being called a lot of times, and this one is only calling it once. But yeah, I mean, this is my call, I think. This is the call. The first call for drawing the red thing. Remember it, please. Try that one. Now suddenly I have a lot of recursive calls. Anyway, it is called minus 20 minus 20, 20, 20, the same fraction. No, not the same fraction. It's a factor of 4 smaller, larger. Minus 20, 20, minus 20, 12.87. Whoop. That's wrong. What a bullshit. And then that one is 20, blah, blah, blah. Okay, that's okay. So this is wrong, and the tolerance is a factor 10 too large. Oh, yeah. T0 plus T0. That should have been a 1. That fixes one thing. And then the fraction is the fraction is 10 times larger. That's indeed true. I mean, the other one uses just so much time just to find the typo. T0 plus T0 plus instead of T0 plus T1. Anyways, so now that reproduces again, it's the same thing. Okay, now I have to implement this function. And that is going to look a lot like this one, though. In the sense that step 1, we fit something. We fit something and then we check. I'll check the tolerance here. And then if the tolerance is okay, then we add it, and otherwise we call this. In the end. So let's start at the bottom. Which is a recursive call. So we just pass P and T and the viewport and the fraction and the orientation. And then stuff that was calculated up here. Maybe I should call it 6. What kind of numbers are we going to use? We get, let's see, so we have 0.0 here, and the G here, and the 1 here. And then if I'm going to split it up, we want to have the old 0, and then a G, and then the old G. So maybe I should indeed call this like something else. I'll rename it in a second. So what we could call this 1, 2, 3, and 4. Could call it 4 instead of 1, I suppose. Yeah, because they the begin and end point need a tangent as well now. So we are entering with not just point 0, p0, but also t0. And then in the middle we just have the point, and then at the end we have the tangent again. So I split it in two. I now need the tangent here and the tangent there, and then just a point in the middle. So we have p0, t0, point in the middle, and then p2, t2. And if this one is then p2, t2, and point in the middle, and p4, t4. Which means that, of course, we have to, at the very least, calculate those things, and they're all vectors. Actually, they're not. Some are points. But I have to pass vectors. It's annoying, man. How does the other thing deal with that? I'm pretty sure I have to pass vectors here, or are they all points? Vectors. Vectors. To func, it returns a point. I can just construct a vector from a point. There. Not even. Oh, wait a minute. Actually, it is explicit. But that works. Okay. So we have these already. I need a P1 constructed from something. And we need a P3. And I need a T2. I think I have the rest. These are being passed. This one is being passed. T2 is now new. P1 is new. And here we have, yeah, P2 is passed. T2 is calculated. P3 is calculated. And these were passed. So we only need these three. Where P is then calculated from P. This P. And T, of course, from T. I'm just do it like this, I think. T2, T3. I need a T2 as well. Let's begin with that then. No. Well, actually, it is called T2 now. Let's call this one T4 then. That was a confusion. It's not T4. So T2 sits in the middle of 0 and 4. Totally doing this wrong again. T0 till T2. And this one is then T2 till T4. I could let this run, but then this never returns because it infinitely calls this. Or we can see what happens if, let's say, well, at the very least I have to fit a Bezier curve. Let's do that first. Let's have a look at the other function again, how does it worked. It's just constructed from points. I mean, result is storing Bezier curves, yeah. So no Bezier curve for me. Just a result dot place back. Yeah, well, yeah, maybe not. Statical result. Then place back. Okay. Okay. So construct a Bezier curve. And the latest constructor that I added is non-existent. Actually, this one. Which I cannot find back now. This whole remark is bullshit. Is the thing even implemented? I'm starting to think that it just has a definition, but not a, well, a declaration, but not a definition now. If it exists, it should be, this is not a template, it should be in this file. Totally does not exist. Seriously. Nope. I think I have to construct it first from the begin and end point. We're going to construct simply from P0 and P4. And then the thing that we got must be made a cubic from. And then pass the rest. Cubic from takes the rest, yeah. T0, T4, and the point in the middle, which was P2. So if now I do a return, then we have a Bezier curve fitted through just one single Bezier curve, fitted as good and bad as it is through the begin, the end, and the middle points. Well, if it compiled anyway. Again, now it's a vector. P2 is a vector, and now we need a fucking point. Hmm. There's a lot of not numbers. Only the first point is correct. Minus 2012.87, as you can remember. That was the beginning. And the rest is not a number. I think the reason is that... I don't know. Well, because there is no... it's not possible to fit a Bezier curve, period. Probably, but... of course, you never want to assert. Whoa, that's a big G. S is twice not a number. The cross product between the two tangents is 0. Doesn't make much sense, except maybe when I don't initialize it at all. We don't initialize it. I was just like, ignoring it anyway. Let's return 0. Yeah. Yeah, we have to pass something that is actually makes sense, otherwise you can't draw it. Okay. So the reason is I'm just returning 0 here, and then the cross product between two 0 factors is very much 0. So this should be the derivative of this one. With respect to W, so I guess this becomes a 1. And then this becomes cubic, the derivative of cubic. I mean, my best guess would be derivative of cubic at W minus X minus 1. You never know, right? Okay, what is cubic? It's probably going to work too. Cubic is a cubic polynomial. Which totally has a derivative. It returns a quadratic polynomial. Wait a minute. So, derivative. Yeah, that should just work. Quadratic polynomial can be evaluated. Ta-da! It actually works. Should work. Compile. If it compiles, it works. It does not compile yet. Minor problem. Yeah, do we need this for the cubic? And I need the X one as well, just the same stuff. Well, if you remember how it used to look, now it looks like this. Is it fooling you? I think I remember that it was going through P1, yeah. It was going like, well, even the tangent is correct, right? Is this horizontal? I think it was like this, and then it goes up. And then it passed to P1, and then it goes down much like this one. So this is approximating that with a single Bezier, in the sense that this point is correct, the end point is correct, the tangent is correct, the tangent there is correct, and here it goes through the same point. But now we have to find out that the tolerance halfway, that it would be in this case at -10, is horrible, like more than a pixel. This is not equal to P1, therefore reject, reject. But I don't know how to do that yet, so instead I'm just going to reject it, period, for a certain depth, number of depth, like one depth first. So simply do if depth is less than 1, I think that should work. Wait a minute, the other way around. If depth is equal to 1, I think depth starts at 0. Then do that. So now we get 2, I think, 2 Bezier curves. If I had added a thingy there, exposed thingies. Make, ding, ding, ding. Brilliant. So now it looks even better, because P1 is now another point where we check it. So now the derivative and the position in P1 is correct as well. This is already almost, perfect. Let's move it around a bit. Yeah, look, this, well, okay. This, I was going to say it's already perfect, but hey, this is more or less perfect. I mean, maybe I should draw the actual function as well at the same time, so we can compare them. But yeah, if you do weird stuff like this, just 2 Bezier curves is not enough anymore. So it's trying hard to, in 0, it has to go through this point. So this is now 2 Bezier curves. So this Bezier curve goes like this, and then the second Bezier curve goes like this, and they should have the same derivative in this point, but they don't, because one of them is negative, so they just point in the wrong direction. I think this one's wrong. This is probably even wrong here. It should have been more like this. Which means that, well, that's an easy way to reject that. I can look at the depth, but let's also reject it if the derivative is pointing in the wrong direction. Then we don't get this kind of weird stuff anymore. Reject as in fall through. So I think I have to create it anyway though, and then reject it by removing it again. Either that or copying it. I have to call this. Yeah, I think I just unplace it and then resize the result. I would destruct the thing exists of, I don't know, a matrix of 4 doubles or something. 8 doubles, I think. Yep, okay, so reject. If not rejected, return. And then boolean reject. No, reject. Reject is something. If not reject, return. And then if we do reject it, we have to remove it again. So just remove the last one, which basically means a resize to the current size -1. That's not a faster way to remove something. Remove the last element from a vector. Probably just a pop back or something, right? Pop back. Surely a vector has a pop back. Let's have a quick search. So standard vector. You have an erase, but that would be a big cannon. Pushback, popback. Yeah, just popback. Returns a void and everything. I mean, you can't get any faster. Well, that's if they unless they implement it in the wrong way. But let's assume that was written by rather good coders. Now I have to write the reject here. I think my cubic from returns something, a vector. So that's a vector S. And then the rejection in this case means that either is negative, either of the coefficients is less than 0. Well, that's rejected even if it is equal to 0. That's definitely one way we want to reject the thing. So I had this, and then I moved it like that, and then something weird happened. But then I don't think it happens. Oh. I lost my mouse. And I can't. The thing is on top of something. Okay, I think I'm here now. Control C. So that is. Wait a minute. Quit. Yes. Yeah. Typing blind. We simply had a 6 sec fault. Try that again while the window is on the other monitor. See what the hell is sec folding. T4 is uninitialized. It should never happen. Sec fold because stack overflow, I think. Yeah. It's infinite loop. But why? the depth got almost 15,000. No, my stack is not that big. I would think that should never happen. If you cut any function in enough pieces, then it should be fittable. In that case, we have to, let's say, put a breakpoint here for when the depth is, let's do break, depth 1, condition 1, depth is larger than 9. Run. Yeah. Was there still a sec fault? Okay, no, what the hell? Maybe I put a breakpoint here, and the infinite recursion happened on 152. I think that is the reason. So we do break 152. See, it doesn't even say. Condition 2, depth is larger than 9. Try that again. Yes. Okay, so this thing was called for minus 20, 20, and then minus 20, 0, and then this one got all the cut closer and closer and closer. And we were never able to fit it. Why? I try to wrap my head around this. We were called with P0 and P4. So this thing is going up. And then of course GDB cannot calculate this. Oh, it can. Okay. That should be kind of like equal to T0. Now you're going to tell me that it can even do this. Okay, I don't have a mouse anymore, but 390,625 times 0. Can you? Could do the other one. Sure, well, not equal, but reasonable. Reasonable. Nothing super strange. So the tangent points in this direction, but it's a bit, this is a bit lower again. So it curves down. So it goes up and it goes down. Let's see. T1 should be... No. No. I hate GDB. Yeah, really, nobody knows what T1 is. I passed it. Oh, it's called T. Does only what? Huh? Okay. Maybe I meant T2, T4. What is this? I meant T4 probably. These are almost the same. I don't see anything on why. I mean, who am I? But there's definitely not stuff like not a number and so. Everything looks completely same to me. So the current frame is here. We have calculated everything. The depth is 10. Okay, whatever. Next. Blink, blink. If depth equals 1. Oops. Oops. Okay. Yeah. No. I mean, this really. I'm wasting everyone's time, including my own. So don't blame me. But the stupidity is again amazing. So before I did if depth is 1, accept it. And then we added the reject, which then calls us recursively. And then you just keep skipping this, which basically means we reject everything. Yeah, Stack Overflow, anyone? How long did it take me that? I got the Stack Overflow and then half an hour at least, I think. At least. Such a waste of time. Okay, there we are again. So now, yeah. So here something happens, and then it divides it in two, and for some reason it doesn't have the same slope. There's a kink here. That should never happen, of course. How the hell can that happen? That's just definitely not good. I think I should start suppressing the green and the purple one, so we get more debug out related to my new curve. That's a green one. BezierFitter on something else. This one, I guess. Its default is blue or so. So far so good. This is probably just too Bezier. Maybe I should, we can do that. You can do that. Wait a minute. I have this fancy macro that shows me which Beziers are being drawn. So that was something within nobody knows. GSX. Something with capital Bezier, I suppose. There we are. Hit in one. Oh yeah, it was in draw, do I remember. I just run this thing without TV. Okay, yeah, so two Beziers. This is one Bezier between this square and that square. And the other one, well, the endpoint drops off the screen. Yeah. So, one Bezier, two Beziers. No problem there. And now I'm going to move this point to right. No, just move it like this. Still a single Bezier. Still. It just... What the fuck? Yeah, there's a new point here. And now there's no kink either. But even before that happens, I think, yeah, here. So before that is splitting this one in two, it doesn't look like this continues, well, like the derivatives continues. Probably it is though. I think we just have a Bezier that curves very strongly. Just before it goes into it, there's no real kink, but it looks like a kink. So that should mean that I think the G value is very large, close to 1 or close to 0. And I suppress that value in the meantime, so I don't know what it is. But this is a pretty unacceptable kink, I think. Let's draw the correct one as well. I mean, this is the Bezier fit, but I want to see what it should be. That would be nice. Wrong file. No, I'm looking at this. It's initializing it, it's just not drawing it. So I just need to duplicate the code that plots it. So to call this alt. Fitter 3 alt. And then we're going to use the other solve, which means I'm passing just a function, and well, I don't have to pass this, I think. And the viewport, and we don't have to pass a fraction here. Let's make that one green, like as in, that's what it should be. Beautiful on top of each other. It's a pretty good fit already, if I say so myself. So so here you have this horrible kink, because the Bezier thing is just, it's a bit off screen. Can I fix it? Oh, like this. So the derivative here is okay, and the derivative here is probably okay at the very last second. I really hope it is. Yeah, it should be. That was the work of yesterday and stuff. So that has to work. I would like to zoom in though here to know for sure that at the last moment it has the correct derivative. Clearly the derivative here is okay. And it goes through the same point here and on at -10 and at 0. And just the derivative here looks really weird. It looks like goes like this. Here you see what it is doing. It's because it's continuous. So the slope is correct. This slope is continuous, yeah, the derivative. And then if we move this like that, this part moves up, but the slope remains correct. See, it's just curving at the last second. I mean, definitely now it's on top of green. So if you was thinking that it is not the same, then it has to be the same because green is definitely the same. And even if you go further now, you see that it does curve here. It does curve here. It's horizontal here, and just so it's going a little bit further. It's going up, and then it just bends and bends and bends and bends until it bends like almost infinitely sharp. It definitely bends. I can't even draw it anymore. Kayo's letting me down. That's bad. What the fuck is this? Bug in the KO window. KO library. Well, I think I want to print the G value of this fits again to see if they indeed get a little bit ridiculously large or small. And I can just reject on that because, yeah, nobody wants to see this. I'm listening to good music. Yeah, it's not plugged through. Well, let's crash that as well. Let's just not start it anew. Okay, what the hell is going on? Why am I not... What? Why does this thing not start if I start it? Where is it? No, you had to run it twice, that's why. Okay, so I want you guys to listen to output of Chromium. This thing is crazy. And the music is gone. No, I can't show. I can't. What is this, man? If I select it, deletes it. Oh, no it doesn't. Have you ever seen anything this unstable? Let's see if we can go back. Yeah, I can. I can not only let you listen to it for a very short moment, I think. Otherwise I get copyright issues. Let's wait for something with a little bit more bass. It goes on like that for a long time. Cool. Yeah, I wish you could just play that, but no. Copyright. Delete your account. You have already had a warning 5 years ago. Those warnings stack up. Let's see. Kajo Hamid asks, why not JavaScript? Okay, I really tried not to laugh. Honestly, I tried. Damn it. Yeah, well. At least you brought a big smile on my face. What would be a good answer here? First thing that comes to mind is I'm not a kid anymore, but I wouldn't mind to be a kid again. So, real men use C++. That would be my second feeling about it. But yeah, I don't know. The real answer is probably some heavily distorted laughter disappearing in the background when I fall down with my chair, literally rolling over the floor. Yeah, well, yeah, why not? My God, it's like the difference between a beautiful life doing C++, doing this in C++, and pure hell. Imagine that you have to do this in JavaScript. Let's talk about euthanasia. No, let's not. Yeah, Tomo, hello. Remember, he was on I'm on every day. Don't tell me I'm not. No, remember. So yeah, I was going to print the G value. So probably G is here close to 0, and in the other case was close to 1. And I want to print that, which means we have to edit Bezier Curve, I think. .cxx. Delta, we don't have a delta anymore. New G, we don't have a new here, really. grep source, new G. Scary. And you're absolutely sure you called it new G? Oh, and then I renamed new G to G, and I called the G previous G. So there we are there, right there, here we are there. And here are the values. Okay, let's print these values again. So apparently G here is 0.46. And yeah, I mean, there's no kink here, right? So it's really the same derivative. Let's go for some kind of kink. Now, of course, I can't make a kink anymore. Can't move this beyond. Ah, there was a kink. Shoot it up, there. And what happened? Still 0.45. I'm shocked. Hey, what? No way. This must be some edge case. Damn it. There's another case where I just want to click on a button which saves all the draggables and then restart the program and get back in this exact situation. I'm just going to need that one day. Okay, what debug can I add so that I understand why this is going in a completely different direction? At the very least, maybe the values of the Bezier curve. Oh, this one then. The moment we leave, I can print all the Bezier curves. And then from that, we can get, I mean, this thing is going down here. Come on, going down. And this one is going up, really. No way. Yep. Okay, so for every, for all two Bezier curves, let's print now I have to go to the fitter. So at the moment that we are not rejecting the thing, we're completely done. I want to print all the Bezier curves in the result, which is just good enough by reference. Bezier curve in result. But I'm not happy with, well, I'm not satisfied, I mean, with just this. We also want to have a lot of information about it. For example, well, let's do trivial thing, just to check it. And then the thing that we're really after, the tangents in T0. How do I get those? Well, P is, I think, just BC dot P in 0. And the tangent is going to be BC dot just the velocity. I can use the velocity vector. There is no member named V. Okay. But there is a member named V0. Actually, there's also a member P0, I think. Let's just print P0. Yeah, and then I have to reproduce it again, again. Let's just drag P1. Try to just drag P1 and then... Oh, we already have a sort of a kink there. So the starting point is minus 2015. Well, totally, right? It's 15 minus 20, 15. And then blah, blah, blah. No, P0 is indeed that. And the tangent vector in 0 is 2 minus 1. Going down. It's just going down. It looks like it's going up, but no, it's going down. That is really the case. So it must be curving like I don't think anything exists in the world that curves this much. Everyone dead. I have to do it in the supermarket, of course. In a minute. So this is curving that hard. Are you really serious? (13.3.0.3). So that's almost horizontal, I would say. Which is not what it should be. Tangent is like that way, man. It's like 45 degrees. And then T0 is 13,1.4. What the fuck? Hi, on dot. Yes, everything is drawn. Everything is being drawn. Yeah. I'm just using the Cairo graphics library. You can search for that, Cairo graphics. Which has support for drawing lines and Bezier curves, yeah, and text, I think. Although probably need another library on top of that already. Or you can just use my free to use open source Cairo window, which I'm working on, and you can do this stuff yourself. Okay, this makes no sense whatsoever. Why is this 2? Hell, why is it 2? I mean, as in positive. I must not be understanding something about it. Okay, because I apparently don't understand it, we are going to do the following thing. I'm going to get the point here at -20. That is this point here, right? P0. That is at -20. Then we're going to get the point at -19.999. Or now, well, actually -19.99 is probably good enough. So very close to -20. And then we have 2 points. 1, 2, and I'm going to calculate the vector from one point to the other one, and then get the direction of that, and then print the direction, that unit vector. And I'm going to turn this in unit vector as well, and those should really be the same. And if they don't, then I don't understand this value. So then I'm going to think about it again. So, well, I don't have to loop over this either, of course. We are only interested in the first one. So we take the front here. That's the first Bezier curve, and then we print, well, what you just printed. And I'm printing the following information. Wait a minute. So this is the velocity. Let's print that as a direction. Then make it turn it into a unit vector. And I'm going to print, whatever direction. Going to print something. But probably have to put that between parentheses because this is a very low, whatever the name is, precedence. And the something between parentheses is going to be P0 subtracted from the P at -19.99. That should be a vector. So subtract this. It should be a vector pointing from here to there. And then that being a vector, I can turn that into a direction again. Yep. So my library, I call it the library, is supporting anything that is intuitive. So in this case, P is the point. So sorry, that must of course the Bezier curve, a point on the Bezier curve at yeah, I don't think so. Sorry, it must be in the neighborhood of 0. So let's do 0.01. Still, is that maybe not enough? No, it's thousands. So P0 is the same as P at 0, and this is then any point at t equals 1000. So that is a tiny little bit on the right of the t equals 0 point. And then if you have 2 points, you subtract 2 points, you get a vector. That seemed to be the most logical thing. And then I can turn a vector into a direction vector, obviously, by dividing it by the length of the vector. I mean, suppose you had a vector and you could not turn it into a unit vector. That would be stupid. Therefore, we can. Direct, now we have a point. For some reason, apparently, it's just everything I just said is not true. Okay, P of Bezier curve returns a point. So this and P0 returns a point as well. No, P0 returns a vector. Oh. Yeah, that won't work. If you subtract a vector from a point, you get a point. It's kind of weird though. I thought that P should... Why is that returning a vector then? So I can either subtract 2 vectors or 2 points. So let's subtract a vector from a point, and I'll just turn this one into a vector. So that is a point, but now it's a vector. Wait, there's another way to do that. I think I have another thing called B. That is the same thing, but then returning a vector. See? Yeah, like literally. So, okay, we just call B and then we get a vector. So now we subtract a vector from a vector, and then at least we can call direction again on that. Vector minus vector is a vector. I was almost thinking I was making a fool of myself, but no. Almost, but not really. Point minus a vector is a point, yeah. Now, as you can see, they are the same. Which is still pretty shocking. So the thing is pretty... It is actually just going horizontally. X is super big and Y is almost 0, so it's horizontal. Yeah, well, that's indeed what it is. it's totally going horizontal here. Okay, so now we move this thing so that now they are different. I mean, these two are different, but now here at this point, the curvature is still going down, I think. And down means a negative y value. It's only a little bit, apparently. Yeah. Okay, so now I was moving this one. Let's move this one such that we get this 45 degree again here. No, 0.707, you see? That's what it says, both. And this one's negative. And these are still equal. So it's absolutely no problem whatsoever. The only problem is that before I had a t0 that was not a unit vector, and it was 13,0 point something. And now they are suddenly equal values. What the hell? How? Now I want to see that back, because no way that can be turned into this direction vector. So I had a V0. I just was printing V0. And if you call direction, what that is doing is you call it vector, I think vector, yeah, this one. It changes the coordinates of the vector into a point and then constructs a direction with that, apparently. And my direction can be constructed from a single point, which then uses a direction from 2 points, namely the origin and the new point, and that thing is giving back the direction from a point from 2.2. It calculates the difference, but yeah, I mean, from is 0. So this is 0 and this is 0, so this is again just equal to 2. And then we calculate the length of that, and then we divide x and y both by that length. So if one of the values is 13 and the other is 0.3, then we get 13 squared plus 0.3 squared is, and then the square root is 13 and a little bit, divided by the 13 divided by 13 is 1, and 0 divided by 13 is 0. And not 0.7 and 0.7. No way. I don't really totally not get this. But anyway, yeah. No, there you are. Well, actually, no, not. Okay, now it's big and small, like we said, but then now this one is also big and small. Okay, now I made it 45 degrees-ish, like this. And you get twice half the square root of 2. And now this is also has the same size. I don't know what I was looking at. I'll just have to look my video back, I guess. My own video. My own stream. Okay, back to the kink thing. So, what the hell do we have in this case? So these are still the same-ish. And they are also negative, going down pretty much. Not 45 degrees, but yeah, this is not 45 degrees. It looks totally correct. So there must be an incredible curvature here. It's really going down here, and then curve, and then going up. And all that with a G of 0.45. What am I not getting? How can I detect that it has a crazy curvature? I really don't get this. Okay, I'm going to zoom in, I think. But that means that I have to either implement a zoom or implement save to disk or print the coordinates of these values and then hard code them in, which is the fastest thing. So I'll not do that, I guess. P0 and P1. Ratchet or draggable. Maybe we can just print what the value is here. It's a result is new position. So basically want to print result every time you move it. Might as well do that here. maybe we move both. Okay, but just moved P0. It's not very accurate though. Might be accurate enough, but try these coordinates for P0. Okay, that reproduces. So now we have a seeming kink. Yeah, well, not. I'm already seeing. It's just curving like crazy. I just don't understand how it is possible even to curve this fast in such a short distance and then still do something sane for the rest. Okay, we want to zoom in on this point, around this point. X zoom is that. Double Y zoom is that. The zoom window is going to be 0.1 for start. XZ, comma XZ minus ZW plus ZW, and then here the same thing but then with a Y. Substitute X, Y everywhere, or not. Why am I not looking? Substitute X with Y everywhere. That works. Or not. It's because this had to be called YZ. Did I make more errors? Disappointing. Very, very disappointing. No curvature whatsoever. Did I zoom in too far or what the F? Really? Oh, wait a minute. I think this is the viewport. So I changed the viewport that we passed to the BezierFitter. That's not what I should do, I guess. I want to keep all these viewports the same. Well, the old one can use this viewport. That's just whatever. But this one I want to keep the same. So plot viewport, the type of plot viewport. Dit is plot. This is rectangle. I think. Yeah, it's even the only one. So let's make a rectangle here called viewport. Constructing it from -20 to 20. Well, actually, the rectangle is something else. But I'll fix it in a second. This must be just a viewport. See, how do we construct a rectangle? That is a width and a height is the second. I suppose these are the smallest values. Yeah. Contains larger than x. Smallest values first and then the width and the height. How the hell can a rectangle not be defined? Oh, because I'm not using namespace key. Oh no, I am using namespace key. That's not possible, of course. Viewport should be returning rectangles, or rectangles are definitely defined. Oh. Okay, yeah. Don't look. For some reason I thought that this was a scope. Yeah, okay, well, this should work. This is nonsense. Yeah. That's some serious curvature. I think we can easily zoom in another factor of 10 before it becomes super clear. Oh. That was the initial thought to begin with, 0.1. Yep. Okay, so now the proof has been given that the tangent is actually correct. It's just something that is curving like crazy and then going, I don't know what it does. But this is pretty unacceptable. I mean, it's really deviating so fast from the real function that if you zoom out, it doesn't look like it connects at all. How to detect this? Or I can just rely on the vertical distance. Halfway, I suppose. But still, what is this curvature? That is the acceleration then, right? So the thing has an acceleration that is huge in the direction perpendicular to the velocity. Then you get a huge curvature. But nobody knows when it is too large. That's a bit vague. Yeah. So I suppose I just have to do with this distance. If this distance is not zero or almost zero, then it's not good. And if this is on top of that, yeah, then maybe it's going like this, but who knows? Who knows? Let's just finish the function before it is 10 o'clock. Okay, so we have to extend the reason to reject it. I have to do a chores, it tells me. Plastic afvalbuiten. Can do that after 10. I don't want to wake my neighbors, but I don't think they even go to bed at 10 o'clock. Plus, it's at the front and they sleep at the back. Reject. Yep, they have to calculate the vertical the orientation distance between P1 and the curve and P3 and the curve. That is not easy. I was working on something that shows the shortest distance between a point and a Bezier curve, but that was using always direction perpendicular to the curve. And in this case, I would rather just draw a line and then find the intersections between that line and the Bezier curve, which is something else. I don't have that yet. So I need a new function, I think. Let's call this distance 1 is the Bezier curve no, I'll just call it distance, I guess, and then we pass the point and we pass a vector along in which direction we want to measure the distance. So along which we want to measure the distance in either direction. So that then is a direction vector, or let's call it D1 for now. And then we have the distance from point 2, 3, I mean. And then I want to reject that if the distance, and I guess I need a distance squared, most likely it would be beneficial to just return that from the beginning. So I'm gonna say get the distance squared. So I guess if either of those distances is larger than something, I need it twice, so I might as well bring in a new variable here, max distance squared. Now theoretically I do not really have to calculate this one if we already reject it based on something else. So let's use the Boolean sort circuit and not calculate these things until we actually need it. So I'm going to replace this with that. So now it gets rejected because of this, and we don't even calculate the distances. And if it gets rejected based on this, then I don't calculate the distance from P3. But I still need to define D1 and D3. That's probably cheap enough. I'll make those vectors. I hesitate to use direction vectors because then I have to calculate the square root. So we can avoid it. I probably can avoid it, so yet I call them D. Well, it literally depends on the orientation. So if the orientation is orientation vertical, which one came first? Actually, horizontal. Horizontal. Let's begin with horizontal. I have a can I create a vector from a direction? Yeah, you can, but it's going to do a multiplication with 1 then, but that's probably okay. If I don't pass a length, I think that is pretty much. Oh, I have a direction called up. Up, down, left and right. That's something else. Anyway, I'm pretty sure I have a direction up. Yeah, there it is. Up, just, I don't know, 0, 1. So if the orientation horizontal, that's why all my viewers leave, because I'm doing such stupid things. Up for vertical. And if it's not horizontal and not vertical, then it's the other thing. Then you just want to have something that is perpendicular to. I think then I have to call t to get the derivative in this point, I think. So the t at t1 but that is in the direction, so I need to rotate it. I think I'll just have a rotate something clockwise. No, 90 degrees. Still nothing. Just 90 degrees. Yay! Yeah, well, counterclockwise. Okay, good enough for me. It's the only one we have. As long as it's 90 degrees, the direction doesn't really matter, right? No. I mean, if it's one way or 180 degrees rotated, it doesn't matter. So this is perpendicular to the real function. And now we're going to draw a line through the real point, which is P1. So we draw a line through this point in that direction, and then find the intersection with the Bezier curve, and then return the shortest distance. So I still have to write this one. It's not D, it's a D3 or D2, I mean. Right, so yeah. Now, what is the maximum distance squared? You shall have to calculate that one as well. That one also depends on the direction, I'm afraid. That is the square of something, being, again, depending on if the orientation equals horizontal. Let's write this like so. The orientation is horizontal, then I want to have the fraction of the horizontal viewport. Why the hell is this an intersect rectangle? It's not easy to work with at all. I probably did that because the other function is using the x and y coordinate, like literally. No, it's also it also needs a distance. This is the width, that is the height. Okay, but it also needs it directly. Maybe I'm gonna need that too. Oh well, I'll keep it like this for now. To width. But on the other hand, if the direction is any, then I'm kind of allowed to assume these are comparable. I'll think I just use the horizontal one then. So really we'll want to use this if it is vertical, and then this if it is horizontal or any direction. So it's more like, if it is vertical, I want to use that. And otherwise, we want to use that. Which means I can put fraction here, or not. Remove it here. Simplify the line. Do not forget the parentheses around your tertiary operator, which is a super low precedence. Yeah, no parentheses needed, except around the whole tertiary operator, like these parentheses. These are necessary, otherwise you're going to multiply that with that first, or with that, and then do the question mark. No. I think everything will fit on one line now. No, then you still need to implement the distance squared, which is a damn difficult function, I'm afraid. That is Bezier curve, right? Oh yeah, you have the curvature, so this should be high in that case. The curvature at t equals 0. And so on could be calculated. Let me add it here. Was it a point? It's Q, I think. So if t is 0, this is Q, so it goes through Q. And obviously, if t grows, it goes in direction, right? So this is the line through Q with this as direction vector. T is maybe a bit overused. I don't know, I'll choose something else. Is Q. I've been using alpha also all over the place. Kota, how is you? Yep, I need to write this function and then I'm done with this, with whatever I described in the description of this video. So I have a point Q and I want to find the intersection point with a line. Not easy. Starts to be the most comprehensive, no, most, not comprehensive, what is the right word here? Most complete, extensive, Bezier curve library it is. The amount of formulas and mathematics that I have into this is starting to really pile up. You want it, I have it. I have it in my head. Do you need a picture? I can explain it. I had a function that did give me a distance, so I'm trying to find that back. Quadratic, linear from, extends. It's not here. Maybe it's still in the test. I'll just add something here. Well, it's quite trivial. I just wrote it in the comment, in the header file. It's just this here. The square of the distance between a given point Q and the Bezier curve. This is a member function of the Bezier curve. But then not just the shortest distance, but the shortest distance if you just move along this direction. So really just draw a line through Q in this direction. And that intersects the Bezier curve, I am afraid, in at most 4 points. Which means that we have to solve a fourth degree polynomial to get it. And then there is another problem that I have to ignore the solutions that are intersecting with the points outside of the interval 0 to 1. In which case we have only 2 intersection points, but the formula is still a fourth degree polynomial, I'm afraid. Anyway, what was that? I think it's just this one, the cubic 2 thing. This one. I had a Q in there, and then we did do the distance. It's probably commented out. It's probably just this. This is it. This is the function. This is the code that I had. So if I uncomment this one, then we get a nice distance, I think. This is using a plot Bezier curve. I'm not sure I want to use that. Well, it exists, so why not, I suppose? Which is drawn twice, okay. Yeah, this should work, but I commented out Q as well, I think. Plot Q. No, I didn't. Just the comma was commented out. Slider was commented out. I'm getting you a drawing very quickly. As soon as it compiles. No variable conversion from vector to point. Again. My P1 is a vector. Well then, just accept the vector here. It's not like I implemented it already. No. Should make that private as well, I suppose. The function. The distance function. Let's see if it compiles or make it private. Distance. No. What the hell am I doing in fitter? Okay, screw this. I just make it public. So here you have a point Q, and it just shows the shortest distance to the Bezier curve. To the quadratic Bezier curve, which is not what we want. We wanted to have to point to the cubic Bezier curve. No, I'm doing all that, and then if we run it again, it's reset. I so need to implement this. That the dragging stuff, I mean, just stays where I last closed the window. I'm going to do that soon. Think. What was I going to do? This is really scary, you know, this kind of blackouts. I don't know. Oh yeah, now I know. But it's, I mean, at some point I just will not remember it anymore, and then I'm senile. That's the end then. I hope I'll forget my password of YouTube before that happens. Yeah, so I was, I want to have the distance to the other Bezier curve. That's what I want. Distance. Not really. Oh yeah, this is using plot. Why the hell? How would plot Bezier curve be the quadratic one? Because it is the quadratic one, and I called it plot Bezier curve instead of plot quadratic Bezier curve. And this is the real one. Plot. No, actually it's not. Well, it is. Yeah. No. It's totally not. Oh, this is the Newton-Raphson thingy. Yeah. Okay. Can ignore that. I guess this is the one. I should stop calling alpha beta. I renamed that to S like a million times. I'm very confused. That's what I want to use. Plot BezierFitter, but I don't because. Huh? No. Oh, wait a minute. Okay. I want to use this. I want to use a single Bezier curve. So I want to use the curve that was used. So it is this thing here, Bezier curve. That's the only thing we have. Bezier curve. Oh, this also never happens anymore. Okay, this is always true. Yeah, okay. So now this thing shows the shortest distance to the red curve. And what I want now is to change that into giving Q a circle with the vector, so I can change the direction. And then it shouldn't take the shortest distance. I mean, now this is just a 90-degree angle with respect to the red one. But I just want to draw a line and then find the intersection point. So then it should point from here to there if I set a direction like that. But I think the code is almost as difficult, as complex. To also note that if you go beyond this point, it just doesn't exist anymore. I don't want it to report this distance. It just doesn't belong to this curve then. It belongs to the curve that starts from here and not another curve. So if we would say be if we do it like this, say, and then vertical, then this distance, this is the distance to that curve. And then there is another curve here, and then the distance from this point to that curve is that distance. So it even switches. The shortest distance then is shorter for another curve, which makes it even more complex. You have to figure out which curves it belongs to. Which is not the case here, I think, because it just knows. Why is that? I had a reason for it. It just knows that it belongs to this curve or not. I think the reason is that the distance that I do calculate the distance to this extended curve. And then if that is shortest distance, then we reject it. The reason was that if you add another curve that starts with the same derivative, then no matter how hard that bends, this Q is going to be closer to that curve while perpendicular to it than to this curve. So it's pretty complex, but let's say if this thing goes straight ahead, like so, then the perpendicular distance would be from here to there, yeah. And then the thing is that if in fact it curves, let's say it's not going straight, but it curves like up, then the shortest distance is going to be shorter, because now the shortest distance is here. There is no way you can pass Q without getting a shorter distance. And at best you can go through Q, but then, well, the distance is 0. And if you bend the other way, then there is always going to be a point on the curve even closer to P0 than the point that you have now. That's perpendicular. So let's say you try to go, you run away from Q, so you curve like crazy this way and then run away. Then there is a sharp bend here, therefore there is a point here close to P0 where the curve is perpendicular to Q. Which means that the worst situation that you can have is, so the worst situation is where the distance to P0 itself is the shortest distance. So that's when I reject it. If P0 is closer than any other point, then I reject the whole curve. But I don't think that is the case now, because for example, if this would be if we have to do this for an arbitrary direction, let's say a vertical direction here, then it is possible that this part that we are here, which I normally would reject it, so a little close to if now this thing is curves away like crazy, so completely avoiding the vertical distance, there is there's nothing here, then the shortest distance is still that point. On the other hand, that would mean that vertical distance should belong to a real function, not something that curves backwards like this. So yeah, maybe if we're talking about a parametric thing like this, which is goes around in every direction, then it's definitely not going to look at the vertical distance. But so the vector that I pass is going to be perpendicular to the real velocity in this point. So if the real curve goes through this point, the point is that it goes through this point then. This is a point on the real curve. So the distance is kind of, per definition, 0 then. No, wait a minute. This is the real curve and I want it to be... I want to know if I have to reject this thing or not. That depends on... No, I can't wrap my head around it. I think it's even more complex than the other one. It's kind of hard to know where the Q belongs to. If you put it here, then you still have the same problem. If the underlying real function is curving backwards a lot here, then the shortest distance to this curve is this, which is shorter than that. So then still the question is, where does this Q belong to? Does it belong to this curve or to this curve? Did not reject this one. I think that I think that we know that it belongs to a certain curve though, because P0 is generated by passing in the parameter that generates this curve. So t runs from 0 to 1. And q is also generated from that. So if I ask my underlying function for the point at t equals 0, and I get this point, and I ask the underlying function for the point at t equals 1, which is this point, and then I ask my underlying function for a value for t equals a half, right? And that could return this q, whatever. I mean, it'll more likely there, but okay, let's just say it's here. Then I just know that the function is going through P0, then it's going through Q, and then it's going to P1. So no matter what, it just belongs to this curve. If this Bezier does not fit this Q, then it doesn't matter that this Q is super close to the Bezier that goes here, or the continuation of my underlying function passes this q very closely here, because that's for a negative t. So there is, I never have to reject it. I never have to reject it, except suppose that, because I do get the derivative of the underlying function in q as well. So I know that it goes like this, and I suppose it goes like this, and suppose it goes down and then passes through q here vertically, and then goes up, and I know that it also passes through p gamma, although I don't look at the derivative there, so it passes through it, and then it curves like this, and the tangent and stuff is the same again in P1. So like this is my real function, like all the way like this, and then curve like that. And then I am wondering, does this Bezier fit that function? No, it fits this point, it fits this point, it fits this point, it fits the derivative, it fits the derivative here. But Q, does it fit Q? Because in Q it says that the derivative is vertical. And then I rotate at 90 degrees, so then we get a horizontal distance. I'm looking for the distance with the fitted Bezier curve in this direction. And there is no intersection at all, not between 0 and 1. So then the conclusion is that it doesn't fit. It doesn't fit at all. I could extend this one, and then we find, say, the intersection with this point, but it's for a negative value, so yeah, no way. Well, actually that doesn't matter, but the fact that that it's different doesn't matter, but it does matter when it's negative. It's really wrong. It just can't be right. Now something that makes more sense, you put it here. So say the real curve goes like this, but then it goes through Q, and then it goes through gamma, and then it goes like that. So there is still this distance. But then the curve is more like this, say it goes like Q, almost horizontal. So I would not measure this, I would just measure the vertical distance. It is just slightly larger than what I get now, but well, I think it would still be better. Yeah, okay, so I think I just have to draw the line and then find the intersection points, and then reject all intersection points that belong to a t value less than 0 or larger than 1. But still we could get multiple solutions. Let me see, how many can we have? A maximum of three. It's a cubic Bezier, so why not 3 points? So if Q is here, say Q is here, and the real curve is going horizontal here. So we would draw a vertical line, and then there is 1, 2, 3 intersection points that are all have all belong to a t-value that is in between 0 and 1. 0 is here, and then we get something larger than 0, which fits, and then around a half, which fits, and then something that's still less than 1 that fits. I think you can have at most 3 intersections. So there must be some cubic that it's a cubic polynomial that gives me the intersection between a given line and the Bezier. Except that now I'm ignoring that it continues here. I'm not sure. I mean, this thing has 5 intersection points. I just show 1, but there were 5 of them. So I'm not sure that the 3 is correct. Let's ask a ChatGPT. It's as if it possibly can know this answer, but you never know. Yeah, that's right. So a line can be described like this, where x and y are then the coordinates on that line. And both the x coordinate and the y coordinate of the Bezier curve are at most 3rd degree of t. So this is at most a 3rd degree polynomial. So the answer is 3. I agree. I think that what was the reason then that I got 5 points in here? It had to do with the fact that I calculate not in it's not a straight line. It is finding all the points on the curve that are where a line to the curve from Q is perpendicular to the curve. So that would be like yeah, in this case 1, and then there's another one here, 2, another one here, 3, and then another one here, 4. That's 4 already. You can get 5, I think. But a straight line can never cross it more often than 3 times. Yeah. Well, that should be relatively easy to do then, right? Probably should do this with Octave to make sure that there are no errors in the mathematics. Yeah, solve for T, sure. Unfortunately, that's what we have to do. Yeah. Right. Go to Alt Tab. I hate it. I hate it that the mouse jumps where you click if you paste something. Pasting should happen where the cursor is, not move the cursor and then paste all at once. No. It took me many months of working with the Bezier Curves until I settled on the fact that the best way to work with Bezier Curves is simply like that. All those shitty other formulas, they're just way more complex. Everything you do is more complex. The only reason to work with this thing is because now if you graph it, I mean, you really have to graph it and look at it before it makes sense. Then then the P1 and P2 kind of have a visual meaning-ish, you know? But if you're doing just mathematics and write a computer program, don't use this formula, really. It's just nonsense. And it is, again, a proof. You know, it's just a proof that I'm right. This is a billion times even more simpler than what it came up with. And the reason is that everyone is talking about Bezier curves in terms of that difficult formula. Sorry, where was the answer? Scroll. And then, and therefore uses that formula. Just Bezier curve, come up with that formula. And then you get this. Well, you can also use this. So this is just, I can make AB a vector, and then this is the dot product between the first column of my matrix and that vector, and so on. And this one needs C to be added. That's it. I wonder if there's not a single expression for this. Just doing a dot product between a vector and a matrix such that you get another vector. Apart from the plus C there. How do you make a vector that is the dot product between each column vector of a matrix and another vector? So that's just the matrix transposed and then multiplying it. Yeah. no x. Oh, dat is verdumpte x, hè. Okay, so let's redefine L. I wonder if they remembered somehow that I was using eigen. You can peek into these things. It could, although it's nothing. It's nothing. The thing it remembers that it says here is just that it did not remember anything. It's kind of weird. Why would it? But you would have to explicitly say remember, and then I tried that, by the way, and it didn't pop up. Because that is not working at all. Yeah, okay. Well, I'm going to have to call it a day anyway. It's definitely getting too late. Do have to play chess though. I have to defend this and this. So there's only two options. Which is better? To remove this, it takes here. Probably. Check. Well, you have to take back, of course. And then nothing. If he takes the queen, I exchange the queen. Oh, I did it again. Why? I wanted to do this move before and then I rejected it because you can just take here. Well, it didn't for some reason. But what can I do about it now? Nothing. Still, I have to go like here now in order to defend that one. And then you could do this and go away and then take here. And I take and I take and then my rook is attacked. And not threatening mate. I can go here actually now. After the rook is moved. That is. So I move the rook, check, I go here, check again. I think I lose on time anyway. Let's try this, but it can't be right. I'm trying to hang on to some kind of pawn that I should give away. Yeah. Yeah. Let's play Italian. What is the best move here again? It seems that sacrificing here is not the best move, even though you remove the castling. I think I have to take here. Yeah, nobody becomes very happy of this either though. Now I have to move my knight all the way back, really? I am afraid so. Maybe I should have gone here. Oh, drops upon. Looks like he drops upon. Yeah, I don't have any development. Just my queen is out. It's pretty horrible. Pretty sure black is completely won here. I would play the queen or something. Yeah, exactly. What a horror. He's forgetting one thing though. Maybe I should not have on that. Just maybe. Just maybe. the bishop comes there, I'm fucked. And I win on time. Evil laughter. It's a draw. What was winning here? Oh no, I gave it away. No, I didn't, because I was winning on time. Seems I was better most of the time. I think at some point I was completely lost. Like, completely lost. You had me in such a stronghold. Yeah, what to do here on this, guys? Just take is the best. Put the bishop back. So what about this move? Oh, here, really horrible. Really horrible. But I went like... Oh, also really horrible. Yeah, okay. So that was that. That was the problem. My knight has to go back. This is like -3. Unbelievable. -3.9. One shitty pawn back, but no development whatsoever. Still -3. -3.5. Okay, he was a little bit not attacking and thinking about his king, which should have given me the time to develop my knight, for example. But no, I moved my queen back. -6. Still -6. Playing like a computer here, man. I'm doing all the right moves. Except no. Actually, I did. Yeah, he should have taken my pawn. I think I made a mistake here by taking my knight. It's now -3 and then dang, draw. Yeah, that was just a stupid move. King forward. Yeah, yeah, why not? I was afraid for this check then after this move. That's why I first did that. No, plus something. Why would I put my bishop there? Oh, to free my rook. Yeah, stupid move. Plus 1.3. This is apparently a stupid move. No, I have no clue. Yeah, I free his bishop. Probably should have just keep this blocked. That's why going here is better. And then maybe bishop here and then give check. Keep that pawn there. Now his bishop is playing as well, so now it's a draw-ish again. I could have taken the bishop with check. Why the hell did it not do that? Draw if he would take my bishop, but he did not. I could have given check, which I didn't. So draw again. Yeah, I could give check again. Now finally I did that. And I did that too. And I should have collected that pawn, but I didn't. +2. How the hell I don't see that? It's just a completely free pawn. Yeah, he lost some time here. Well, kind of the same effect, I would say. Or not. He goes here with the tempo and the bishop. Tempo and the king. King escapes. Oh, my pawn hangs. Okay, let's first go here then. Nou, do a random move. And now then this. No, because the bishop. And here but so here I can do this because he can't do this because I take the rook. And that's no longer the case. Sorry, I went forward then. I thought this was a move. Didn't still take it. There's no problem. But black is winning. Why? Oh, my bishop hangs. That's why. Yeah, I went here and then. Okay, whatever. I'm going to bed. So what I have to do for my program tomorrow is finish the quadratic distance thing, squared distance squared thing here. That's where I am. Okay, good night.